All right, section 1.3, average rates of change. It is exactly what it says. An average is when you add things up and then you divide by how many there are, and it is a rate of change. It's how something is changing over time. Um, so what we're going to talk about today is how we find an average rate of change, which is actually just going to go back to some basic algebra, and then we're going to talk about how that's going to progress forward. So our objectives are to compute an average rate of change and to find a simplified difference quotient. Um, when we get to that, you'll understand the importance of it, or hopefully you'll understand the importance of it going forward. Some of the vocabulary, average rate of change, we just talked about that. Secant line, which we will discuss how that relates to the average rate of change, and then difference quotient. It is exactly what it says. You are taking the difference and a quotient within one thing to simplify. All right, so let's start off with something basic. Suppose some Wednesday afternoon that you drive 120 miles from Anne Arundel Community College to Ocean City, Maryland. You leave at 1 p.m. and you arrive at Ocean City at 3:30 p.m. We want to simply know what the average rate of change or your average speed was throughout the entire trip. Well, if you traveled 120 miles and it took you 2.5 hours to get there, we know that we would normally find um, the average speed by taking the total distance traveled and dividing that by the time. So we do 120 miles divided by 2.5 hours, and that's going to give us 48 miles per hour. So there was an average speed of 48 miles per hour on our trip. Suppose, however, and this is an important distinction, suppose we look at the speedometer at exactly 2:45 p.m. and it reads 55 miles per hour. Well, that's not your average speed because we already figured out the average speed was 48. The speedometer read 55 miles per hour. So does that mean we did a calculation incorrectly? No, we didn't. What it means is there's a difference between the average speed that you go the entire trip, because we all know that as you're traveling, you don't hold the exact same speed no matter how hard you try. And even if you have, cruise control, it's not going to keep that same speed exactly the same the whole way. Your speed will fluctuate. Um, but at that one specific moment when you look down at the speedometer at 2:45 p.m., it said 55 miles per hour. That is what's called your instantaneous speed. Okay, instantaneous speed right there. At that one moment in time. The average, however, was 48 miles per hour. Okay, so let's go ahead and take a look at example one. The graph below shows the total production of suits at Rags Limited during one morning of work. What was the average number of suits produced per hour from 9 a.m. to 11 a.m.? So the first thing we have to do is kind of read the graph here. It says on the bottom here that the time in number of hours since 8 a.m. So that means that time 0 is 8 a.m. So time 1 is really going to be 9 a.m. So we're going to be interested in that time. And 11 a.m. is going to be 3 hours after 8. So that's going to be out here, 2 hours after 9. So what we're looking at is we're looking at this value right here and this value right here. So according to this, in the 2 hour span, we went from, it looks like, producing 20 suits to producing 64 suits. So it looks like we produced a total number of suits of, what is that, 44 in that 2 hour range, because we went from 20 to 64. So we produced 44 suits over the 2 hour period. So the average is going to be 22, I guess we'll say, suits per hour, SPH. That is your average. That's what the average was. Now, if you're really looking carefully at what we just did there, we really just found the slope of the line segment between those 2 points. If we were to draw, let's do this in orange. If we were to draw a slope or a line segment between those 2 points, and you want to find the slope of 2 points, It's just y2 minus y1 over x2 minus x1. That's exactly what we just did. We did y2, which is 64, minus y1, which is 20, over x2, which is 3, minus x1, which is 1. So we got 44 over 2, which again is 22. So when you're finding the average rate of change, all you're really doing is finding the slope between the 2 points that you're finding the average rate of change. This is actually what is known as the secant slope. When you actually find the average rate of change between two things, it is called the secant slope, or it's the slope of the secant line, which is right there. The slope of the secant line is between the two endpoints. Okay, the reason that that's going to become important is because there's going to be what we're going to talk about shortly, which is called the tangent line. We'll get to that in a minute. All right, for reasons which are going to become clear in the next section, we're going to be interested in finding the average rate of change of a function f of x from x to x plus h. So let's take a look at this, this graph over here, just so you have somewhat of an idea what we're looking at. If I want to find the average rate of change between this point and this point, what you can see is that we did draw a secant line right through there, right through those 2 points, and we labeled each one of the points. Now the first one, we just labeled x as the x value because it's just in general, and f of x is the y value because the f of x is the same thing as y. It's the function evaluated at x. Well, in order for us to get the second point, we had to have some kind of a change of x and some kind of a change of y. Well, we let our change of x be this value h that's circled there. So if I start at x here and I go out and add a distance of h, I'm going to get to x plus h. That becomes your x2 value. And then if I'm going to go from the y value of f of x, which again is right here, this red dot, that's the y value of f of x, but then I'm going to add this f of x plus h to get to here, then that's where the y value becomes f of x plus h. I'm just adding the two values together to get to the y value. This is going to be what's known as the difference quotient, because ultimately this right here is y2, this is y1, this right here is x2, and this is x1. So we're just going to put that into the difference quotient. Well, that's what it shows right here. F of x plus h minus f of x over x plus h minus x. But the denominator can actually be simplified, which is why this thing simplifies down to just h, because if you take the x and you subtract the x on the bottom, all you're going to be left with is h. Can't do the same thing with the functions because those are functions of something, so they don't simplify the same way. Obviously, h can't be 0 here because then we're dividing by 0, and that's a problem. But this one right here, this is the one you're really going to need to know. That is called the difference quotient. Put a star there. That's the difference quotient. So we just want to use, in example 2, we want to use the difference quotient here to, well, we're going to simplify the function f of x using the difference quotient. And then we're going to evaluate the difference quotient when x is 5 and h is 0.1, and when x is 5 and when h is 0.01. So the first thing that we need to do is let's find the difference quotient. That's the first thing. And this is where things tend to get a little bit tricky and a little bit more algebraic. So f of x, let's see, to do the difference quotient, we need 3 things. We need f of x plus h, we need f of x, and we need h. Well, h is just h. It's going to stay that way. F of x is given to us. That's nice. That's x squared. So let's see here. F of x is x squared. So I know when I do my difference quotient, I'm going to have a minus x squared there on the top. I have to find f of x plus h. Okay, so this is where it gets tricky. What you can see, it's not really tricky, you just have to understand what's going on, is x plus h took the place of x. So just like it takes the place of x there, that's also going to take the place of the x right there. So x plus h is going to take the place of that x, but I have to square it. Now remember that you have to FOIL this. This is not just x squared plus h squared. That doesn't work. It's got to be FOILed. So when we FOIL this out, it's really x plus h times x plus h. And I am not going to walk through the entire process there, but we're going to get x squared plus 2xh's plus h squared. That's f of x plus h. Well, that's what we need for the top part of our difference quotient. This is the first part. F of x is the second part, and then we're going to put it all over h. So our difference quotient is going to be x squared plus 2xh plus h squared, that's f of x plus h, minus the original f of x, which is x squared, all over h. And if we've done this correctly, and this is just kind of a hint of what to look for, if we've done it correctly, everything in the numerator that does not have an h in it must algebraically subtract out. And in this case, it does. The first term is x squared. It does not have an h in it. The last term is negative x squared. If I add those together, they're going to be 0. The middle two terms both have h in them. They do not have to go anywhere, at least not yet. So let's go ahead and simplify what we have. So we have 2xh plus h squared divided by h. Well, now what you should be able to see is that we have an h in every term. There's 2 terms on top and there's 1 term on the bottom. So that means that we can divide an h out of every term. If we divide an h out of every term, dividing it out of this piece just gives me 2x. Dividing it out of this piece just gives me h. And dividing it on the bottom gives you 1. Now you really don't need to write the 1, so we can just write this as 2x plus h. That is the difference quotient. And now what it says to do is to actually evaluate the difference quotient when x is 5 and h is 0.1. And then we got to do it again for x is 5 and h is 0.01. So let's go ahead and do the first one. So when x is 5 and h is 0.1, let's erase that, 0.1, the difference quotient is going to be 2 times 5 plus 0.1. 2 times 5 is 10 plus 0.1 is 10.1. Okay, let's do the same thing for when x is 5 and h is 0.01. So we're going to have 2 times 5 plus 0.01, so we get 10.01. Okay, that's what it had us do. All right. Example. I forgot to read the next line. Notice that we're choosing smaller and smaller h values. We are going to relate that to a limit in the next section. So just know that the next time we did it, x would have been 5, then we probably would have picked 0.001 for h, and so on. All right, example number 3. These are going to get a little bit more algebraically challenging, so that's why we're going to work through them here. All we want to find here is the difference quotient. We're not picking any values. Okay, difference quotient. Again, we need f of x plus h, f of x, and h. F of x is given to you. H is always just h. So the only work we have to do up front is find f of x plus h. So let's do that. I need to find f of x plus h, which is just substituting x plus h into the x in our function. So that's going to give us 1 over x plus h. So now I can find the difference quotient and then simplify it. So the difference quotient is f of x plus h, which is this one, minus f of x, which is that one, over h. All right, this is where it gets, like I said, algebraically a little bit more complicated. We need to simplify this. There are multiple ways to simplify a compound fraction like this one. The first thing I personally choose to do is I choose to look at and see what my common denominator is. Well, in this thing right here, I've got x plus h and I've got x. So the multiplication of those two things is my common denominator. I want to use the common denominator to get rid of all of these fractions and make it just one fraction. So what I'm going to do is I'm going to multiply the top by x times x plus h. I'm going to multiply the bottom by x times x plus h. You have to multiply the top and the bottom by the same thing because otherwise you're changing the fraction. All right, so if I multiply the top by x times x plus h, the idea here is if I multiply all of this times this fraction right here, it gets put on top. Well, hopefully what you can see is the x plus h's are going to divide out, which is only going to leave us with an x. Then I'm going to multiply that entire thing by this piece. So we're going to subtract. But hopefully what you can see here is when this gets put on top, the x's are now going to cancel out, and that's going to leave us with only x plus h. And in the denominator is going to be everything multiplied out. And again, I'm not going to simplify any of that yet because we want to start seeing if anything's going to go away. So I'm just going to leave it as h times x plus h. All right, let's simplify the top. The top is going to be, if I distribute the negative sign throughout, I'm going to get an x minus x, which is 0. But then the negative also gets distributed to the h, so we get a negative h. And on the bottom, we get h, x plus h. Now, hopefully you can see why I chose not to distribute stuff, because now we should be able to see that these h's are going to divide away. So what that's going to leave us with, don't forget that there's still technically a negative 1 on the top there. We get negative 1 on top, and then x plus h in the denominator. That's the difference quotient for that one. Okay, we've got one more example to do here of this one. Example number 4. For f of x is square root of x, we want to find the simplified form of the difference quotient. Once again, we need to start off with the exact same premise. We have to do f of x plus h first. Well, that's going to be substituting x plus h into x. So that's going to be the square root of x plus h. Okay, I have f of x, h is just h. Let's plug it in and see what we get. So we're going to have f of x plus h, which is square root x plus h, minus f of x, which is square root of x, over h. In order to simplify this difference quotient, because you might look at that and think, well, there's really nothing to do there. But the whole idea of simplifying the difference quotient is to get rid of the h in the denominator. In order to simplify this, we have to go back to one of the concepts that we did in one of the previous sections. We have to multiply the top and the bottom of this fraction by the conjugate. Now, the conjugate of this one, again, it's going to be the first root and the second root, but a different sign in between. So we have to multiply the top and the bottom by that. All right, so now let's take a look at what we're going to get here. If we were to FOIL this, remember this is basically a FOIL problem. First times first, the square root of x plus h times square root of x plus h is just x plus h. If I were to multiply the inside and the outside, so if I multiply these two pieces together, I get a negative of the same thing as if I would multiply the outsides together, I get the positive. When I add those two things together, they're going to go away. That's the purpose of the conjugate, by the way. You're going to get rid of the inside and outside every time if you multiply by the conjugate. So the only thing I have left to do now is multiply the last times the last. So I'm going to get a minus, and then square root of x times square root of x is just x. So then the denominator, once again, I'm not going to distribute anything. I'm just going to leave it as h times square root of x plus h plus square root of x. Okay, hopefully now you can see on the top here, the x minus the x is going to go away. Perfect. Which is going to leave us with h over h times square root of x plus h, that is an h, plus square root of x. And now the h's are going to cancel. Those are going to divide away. Don't forget, whoops, left the parentheses off. Don't forget that the numerator still has a 1. So it's going to be 1 over square root of x plus h plus square root of x. And that's the difference quotient. A little bit more algebraic there. All right, that's enough for average rates of change and the difference quotient. You should have enough, and we'll put this stuff to use in section 1.4.